So this is the recording of linear programming. Okay, in linear programming, you just understand that every question will have an objective function which is termed as z. Z is equal to, let's say, z is equal to 4x plus y. This is the first example sum. And this is called objective function. The objective function is objective of starting any business is to get a good revenue. I know it could be like we are manufacturing 4 chairs and the cost of a chair and a table or whatever. The purpose of starting a business is known as objective function. The z is always termed as the objective of starting the business. There will be constraints given in the question. What are the constraints? Constraints are x plus y is lesser than or equal to 50, 3x plus y is lesser than or equal to 90, x is greater than or equal to 0, y is greater than or equal to 0. What is the meaning of constraint? Say, I am running an aircraft and what is a constraint? I cannot accommodate more than 200 passengers to fly from Chennai to Bangalore. That is a constraint. More than 200 is not possible. Similarly, I cannot fly the aircraft even without having minimum of 100 passengers because otherwise the airlines will run under loss. So these are the constraints. Okay, supposing I'm manufacturing tables and chairs and I have a godown which can only stock 100 tables and 50 chairs, for example. There's a constraint. I should be able to stock it, right? So these are called the constraints. Okay, so then there will be constraints and there will be objective function. Okay, so now take the constraints. This refers to first quadrant because x is also positive, y is also positive, refers to first quadrant. Obviously, the number of tables or chairs that you're manufacturing cannot be negative, or the cost of it cannot be negative, whatever it is, you will understand. So first we have to plot a graph for the constraints. Okay, let's consider these inequalities. X plus y is less than or equal to 50, 3x plus y is less than or equal to 90 as an equality, which is x plus y is equal to 50 and a 3x plus y is equal to 90 as an equality. And let's plot a graph. When x is 0, y is 50, y is 0, x is 50, and 2 points we can connect and we can get a line. Similarly, x is 0, y is 90, y is 0, x is 30. So thus you can draw graphs. Now with these 2 points available, let's call it as line 1 and line 2. A 50, 0 can come here and a 0, 50 can come here. Connecting these 2 points will result in a line 1. I can do a thick line because it's lesser than or equal to. But it was only lesser than 50, then I may have to do a dotted line here. But as per last year's syllabus, linear inequalities or linear programming, since it's equal to, I can do a thick line and that's my line 1. Let's plot the next graph, which is 0, 90. Where will 0, 90 come? It will be somewhere up. Extend the y-axis and write this as 0, 90 and 30, 0. This will be your line 2. So you just draw the 2 lines. Now go back to the inequality, put here 0, 0 to understand whether the origin can be shaded. Is 0 less than 50? Yes, 0 is less than 50. So for the line 1, the 0, 0 origin is satisfying this condition. So for the line 1, we can shade the origin side. Now take the line 2 and put 0, 0 here. Is it less than 90? Yes. For the line 2 also, this is satisfying. And so you can cover the origin side. So shade the origin side. Now it's also the first quadrant because the constraint is also x is greater than or equal to 0, y is greater than or equal to 0, shows its first quadrant. Therefore, you end up getting a quadrilateral where the intersection of all the shaded region is happening. The left side of the line 1, left side of the line 2, and first quadrant means this quadrilateral. Take these corner points of this region. What are the corner points? You have 0, 0, you have 30, 0. You have 0, 50, but you don't know this corner point of this quadrilateral, for which you should solve this line and this line. Where are the 2 lines? Here are the 2 lines. Just solve them. Take the 2 lines and solve it. x plus y is equal to 50, 3x plus y is equal to 90, a minus 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 is minus 2x is equal to minus 40, so x is equal to 20. On substituting x is 20, y is 30. So you get 20 comma 30 to be another corner point of this region. Once you plot the corner points, you have to put this objective function in here, which you have never used. See, in this, the objective function z is equal to, the first example is 4x plus y. 4x plus y. So take that 4x plus y and substitute x is 0, y is 0. Z will be 0. X is 30, y is 0. 120. X is 0, y is 50. X is 20 is 80. Y is 30. 30 plus 80 is 110. So which is your maxima? This is your maximum. 120. The objective of starting the business, you're getting a maximum objective, and that occurs at a point 30 comma 0. So this is what it is. So let's go to the next example. The second example, they've given an objective function. See, such a region which is, this is called bounded region, bounded feasible region. The name for it is called feasible region, bounded feasible region. Okay, let's go to next sum, which the objective function is z is equal to 200x plus 500y. Then they've also referred to constraints such as x plus 2y is greater than or equal to 10, a 3x plus 4y is lesser than or equal to 24, x is greater than or equal to 0, y is greater than or equal to 0. This refers to first quadrant. Consider these constraints as equality. X plus 2y is equal to 10, a 3x plus 4y is equal to 24. Put x is 0. What is y? Y is 5. Y is 0, x is 10. So you get 2 points with which you can draw line 1. X is 0, y is 6. Y is 0, x is 8. Thus you get your line 2. With these 2 points, you can draw the line itself. And 8 comma 0, supposing it's here, a 0 comma 6 is here approximately. You can connect these 2 lines and draw it as line 1 with a thick line. Sorry, this is line 2, right? 0 comma 6, line 2. 0 comma 6 and 8 comma 0. 0 comma 5, the first line's point is here. And a 10 comma 0 will be here. Connect these 2, you get your line 2. Line 1, sorry. This is your line 1 and this is your line 2. Just extend this axis, this is your line 2. So now take the origin and see if the origin can be shaded. Put 0 comma 0 here. It's 0 is lesser than 10. So this inequality is not true. So take the line 1 and shade, don't shade the origin side. To shade the other side of line 1. Done. Now take the line 2, substitute 0 comma 0 here. Is lesser than 24, satisfying. Okay, for the line 2, the origins side can be shaded. So for line 2, I'm shading the origin side. And incidentally, it's a first quadrant also, as it is first quadrant. And you can see a triangle. I'll do it in different color. You can see the place where everything intersecting happens to be a triangle. I know these corner points. We already know the corner points. 2 corner points is 0 comma 5 and 0 comma 6, which you can put in an objective function, which is 200x plus 500y. However, this corner point you don't know. You have to solve the 2 lines. Take the 2 lines and solve it. You get your x coordinate and y coordinate to be 4 comma 3. Okay, solve with them like linear equation. You get it as 4 comma 3. And so then substitute that also in the corner point is 4 comma 3 and put that in the objective function. Okay, just tabulate it. X is 0, y is 5. You get 2500. X is 0, y is 6, 6 5 get a 3000. X is 4 and y is 3, you get 2300. So you see which is the maximum here and which is the minimum. 3000 is the maximum and this is my minimum. And the minimum is the question. Minimum occurs at a point 4 comma 3. So you know this is the minimum value 2300. It's an objective function. And here again it's a bounded feasible region. It's called bounded feasible region. Okay, so that's about it. So let's go to the next question. Example 3rd is and an objective function is 3x plus 9y. The constraints are x plus 3y is lesser than or equal to 60. X plus y is greater than or equal to 10. X is lesser than or equal to y. X is greater than or equal to 0. Y is greater than or equal to 0. Consider them as equality. Consider them as equality. Consider x is 0. What is y? Is 20. Y is 0. X is 60. This line 1. X is 0. Y is 10. Y is 0. X is 10. This is a line 2. What about x is equal to y? X is 0, y is 0, and then you don't get stuck. If x is 10, y is 10, x is 20, y is 20. So then just draw this 3 lines here. A 0, 20, a 0, 10 is here, a 10, 0 is here. Connect them, you get your line 2. A 0, 20 will be here. A 60, 0 will be here. 0, 20 and a 60, 0. Just join this, you get your line 2. Line 1. That's my line 1. Then 0, 0, 10, 10, a 20, 20 will be a line that's passing through the origin. This is line 3. Line 1 and line 2 are okay. You can check whether origin can be shaded. Put 0 and 0 here. It's less than 60, so line 1 satisfying. For line 1, the origin can be covered. Take line 2 and substitute 0 and 0. No, it's not satisfying. 0 is not lesser than 10. 0 is less than 10. It's not greater than 10. So origin should not be shaded for line 2. For line 2, shade the other side of the other side. Don't shade the origin side. So I know that for the line 1, it's below. For line 2, it's above. But I have to take the other one, which is this x is equal to y. The shading becomes very difficult for line 3 because this itself is passing through the origin. So you have to think whether you have to shade the reverse side of it or the bank side of it of the line 3. Take one example on the reverse side. It's like 0, 10. On the reverse side is the left side, from this side, reverse side. Let's take one point which is 0, 10 and substitute it here. X is 0, y is 10. Yeah, it's satisfying. 0 is less than or equal to 10. So the reverse side can be shaded. So like that, give an example. River and bank. That's river and bank is only for your own knowledge. Don't write it in the exam. So you understand that the line 3, the other side can be shaded. So where is all the colors shaded? Now let's see. It's coming in this quadrilateral because the below the line 1, above the line 2, and also the other side, the reverse side of line 3 shows this is the shaded portion. You have to take all the corner points. To find the corner points, you already know some corner points, which is the corner points are, what are the corner points we know? A 0, 20, a 0, 10 is a corner point we already know. You're going to put it in objective function. But look at this, you need this corner point which is solving line 1 and line 3. Take line 1 and line 3 and solve. You get this corner point. What will be line 1 and line 3? Line 1 is x plus 3y is equal to 60. Line 3 is x is equal to y. So you write 4x is equal to 60. So x is equal to 60 by 4. 4 1s are 4, 5 4s are. So this corner point has got 15 as the x coordinate. What will be y coordinate? 15 plus 3y is equal to 60. 3y is equal to 45. Y is equal to 15. So it's 15, 15 is this point. We got this. Similarly, you should get this point. This is solving line 2 and line 1. Solving line 2 and line 3. Sorry. This is line 1 and line 3. This is line 2 and line 3. Just locate this point. It is line 2 and line 3. What is line 2? Is x plus y is equal to 10. What is line 3? X is equal to y. So 2x is equal to 10. X is equal to 5. Again this is 5 and y will also be 5 because this line itself is x is equal to y. So you got these corner points which is 5, 5 and 15, 15 and put it in the objective function z. You get various values from this quadrilateral. You get 0, 10, you get answer as 90. 5, 5 you get it as 60. 15, 15 you get it as 180 and 0. 0, 20. Yeah, 0 comma 20 you get it as 180, just calculations. Okay, 0 comma 10 is 90, 5 comma 5 gets you 60. So you see that there are two maximas, not just one maxima. Multiple optimal solutions are there. Optimal means maximum. Multiple optimal solutions which occurs at 0 comma 20 and also 15 comma 15. Okay, where is 0 comma 20? I'm going to tell you something very important now. Where is 0 comma 20? It's this in the graph. Where is 15 comma 15? So which means since the maxima is occurring at these 2 points, every point on this line, whatever points you substitute will result in maxima. So there are infinitely many solutions available for you which are between 0 comma 20 and 15 comma 15 which will result in maxima, not just 2. This means there are so many other maximas also. So I hope you understood. The feasible region is a convex feasible or bounded feasible region. So let's go to the next question. So this is a tough question because you had a third line which was passing through the origin, so that will come for exam. So fourth example sum is z is equal to minus 50x plus 20y, and the constraints are 2x minus y is greater than or equal to minus 5, a 3x plus y is greater than or equal to 3, a 2x minus 3y is lesser than or equal to 12, and x is greater than or equal to 0, y is greater than or equal to 0. So consider these constraints as equality 2x minus y is equal to minus 5, a 3x plus y is equal to 3, a 2x minus 3y is equal to 12. And consider x is 0, y is 5, y is 0, x is minus 2.5. Next, that's my line 1. X is 0, y is 3, y is 0, x is 1. That's my line 2. Then x is 0, y is minus 4, y is 0, x is 6, and that's my line 3. So you're supposed to plot this graph. You have 0 comma 5. Let's take, where will 0 comma 5 be? Can I take it approximately here? And minus 2.5 comma 0 will be approximately here, and join this, and that will be your line 1. 0 comma 3 will be here, and a 1 comma 0 is here. Join these two, you'll get your line 2. 0 comma minus 4 is in the y coordinate, 0 comma minus 4, 6 comma 0 is here. Join these two, you get your line 3. So again, you've got 3 lines and you don't know whether you can shade the origin side of it. So take the origin 0 comma 0, substitute them here, 0 0. Yeah, 0 is greater than minus 5. In the number line, minus 5 after the 20 0 comes. So origin side can be shaded for line 1. Take line 1 and origin side can be shaded. So this side of the line 1 can be shaded. Let's take line 2, put origin. Is 0 greater than 3? No. So for line 2, the other side has to be shaded, not the origin side. For line 3, put 0 plus 0. 0 is less than 12. Yes, for line 3, the origin side can be shaded. I'll use a different pen so that we have clarity over the shaded portion. Line 3, left side of line 3 of shaded. So where is all the shaded portion appearing is this open bowl portion. This portion and first quadrant. So you have to cut it like this, because only first quadrant. Cut it like this, cut it like this, and cut it like this. Can you see an open bowl which is exposed to the sky? This is the open shaded portion. It's called unbounded. Unbounded region is what you get. Mark the corner points. What are the corner points? Corner points are, you have a 0 comma 5 and you have a 0 comma 3. So you have a 0 comma 5, a 0 comma 3, then you have a 1 comma 0, and you also have a 6 comma 0. So these are your corner points and the open bowl which is exposed to the sky, and put it in the objective function which is minus 50x plus 20y. Substitute x and y here. You get 0 comma 5, you get 100, 0 comma 3, you get 60, 1 comma 0, you get minus 50, then you get minus 300. And this is your minimum. In this, there will be no well-defined maximum because the maxima goes on and on and on. But the minima, because it's exposed to, it's not bounded, it's unbounded. Only minima exist, and that minima also you have to check whether it's verify whether this minima minus 300 is your minima. For which you should write, take that equation, this z, instead of z you can substitute, it's minus 50x plus 2y, 20y is equal to minus 300, whether this z is minus 300. To verify, you write minus 300 on the right side and put a symbol like this. Is your minimum, which means this equation, minimum means it should be more than that. The equation is lesser and this value is your minimum. This is the way you should put, okay, you should put like this to see if this is minimum. To verify if it's minimum, remember you're writing the minus 300, you're taking this equation, writing it as equality, making sure that the right side is minus 300, and make sure you're putting a symbol like this to verify this is minimum. So then solve this equation. Okay, don't put equality symbol, just leave it like this, mug this up. If x is 0, what is y? When x is 0, y is minus 1 and 5, is it? Minus 15. If y is 0, and so x is 0, y is minus 15. Y is 0, what is x? X is 6. So you get 0 comma minus 15, 6 comma 0 as the points, okay? Very important this sum is, take this point 0 comma minus 15 will come somewhere here. 6 comma 0 is here. Join this line and draw this line. And shade this portion, put a 0 and 0. Is 0 lesser than minus 300? No. So origin side should not be shaded, on the other side should be shaded, and I'm shading and I'm getting this part in the first quadrant, an intersection part. There is a common region, and when I shade this, there's a common region which goes through the feasible region. So whenever it does that, the minima that you get is not the actual minima. Okay, so you should do it using the graph. If you have this thick shaded region, which is as per this is intersecting with the unbounded region, the minima that you got, the minus 300, is not the minima. So when will it be minimum? Say supposing the open region is like this, and you get this line is not cutting through this region. It will come like this. There will be no common portion when you shade this. Then the minima is your minima. I hope you understood. I've done all the examples. The last example is something you can try. You will notice that the feasible region itself, you don't get an intersection region at all in the first quadrant. So there is no feasible region. So you can try all these sums given in the exercise, and you can finish this.